Hello students, in the second exercise, that is 7.2, we solve all the problems by the method of substitution. Now let's take an example and see how the problems can be solved by substitution. The first one is integrate 2x divided by 1 plus x square dx. Now if I try to integrate the given expression as it is almost impossible because I have 2x in the numerator and 1 plus x square in the denominator. So it becomes very difficult for us to integrate the given expression as it is. But if I make a substitution, then the process of integration becomes very simple. Now let me take 1 plus x square. Now if I make a substitution that 1 plus x square equals t. Now if I differentiate this, 2x dx equals dt. So therefore, in place of 2x dx, I substitute dt, and in place of 1 plus x square, I have t. So we get integral, so this is dt divided by t. So we know that what is integral of 1 by t dt? It is nothing but log of t plus a constant c. But what is t? T is nothing but 1 plus x square plus c. So if I do a simple substitution, the whole process of integration becomes much more easier and simpler. The next one, log x the whole square dx divided by x. Now how do I substitute? Now we observe that differential of log x is 1 by x. So let me take log x to be equal to t. And if I differentiate this, so we get 1 by x dx equals dt. So now how do you proceed with the substitution? So replace dx by x as dt and log x as t. So we get integral, so log x is t, so it is t square, and this entire expression is dt. Right? So we know that integral of x power n dx is x power n plus 1 divided by n plus 1. So this is integral t square dt. So integral t square dt is nothing but t power 2 plus 1, which is 3 divided by 3 plus c. Now what is t? T is log x the whole cube divided by 3 plus c. Question 3. dx divided by x plus x log x. So I need to integrate this. So observe that x is common. So let me take x common. So you get x into 1 plus log x dx. Now again observe differential of log x is 1 by x. So let me take 1 plus log x equals t. So this is the substitution. If I differentiate this, differential of 1 is 0. So differential of log x is 1 by x dx equals dt. So what happens? Dx by x, replace it by dt, and then 1 by 1 plus log x is t. So you have integral, so this is 1 by t dt. So what is integral of 1 by t? It is log t plus c. And what is t? T is nothing but 1 plus log x plus c. So this is the answer, into sine of cos x dx. So I have to integrate this. Now we have sine x as well as cos x. So put cos x equals t. So cos x equals t. So if I differentiate this, differential of cos x is minus sine x dx equals dt. So we have sine x dx with a negative sign. So sine x dx is nothing but minus dt. Right? So let's make that substitution. So I have a minus sign here. So sine x dx is dt, and you have sine. What is cos x? It is t. So integral of sine t dt with a negative sign. So we know that integral of sine t is minus cos t. So minus of minus cos t plus c. So which is cos t. So what is t? It is again cos x plus c. So this is the answer, cos of cos x plus c. Problem 5, you need to integrate sine of ax plus b into cos of ax plus b dx. So how do we proceed with the process of integration? So in order to proceed with the process of integration, this is of the form sine a sine b, or sine x cos x. So we know that sine 2x is equal to 2 sine x cos x, or sine x cos x is 1 by 2 sine 2x. So this is 1 by 2 into sine 2x is sine x cos x. So instead of x, I have ax plus b. So this can be written as sine of, instead of x, I have this term 2 into ax plus b divided by 2 dx. Alright, so now we have to perform substitution. So I have this expression 2 into ax plus b. So put that equal to t. 2 into ax plus b equals t. So 2a dx is equal to dt. Right? So what is dx? Dx is equal to dt divided by 2a. So let's perform the substitution. So I have 1 by 2 integral sine t, and what is dx? Dx is dt divided by 2a. So into 2a. So we know that integral of sine t is minus cos t. So I have 1 by 4a with a negative sign cos t. What is t? It is 2 into ax plus b plus c. So I have skipped one step. So I have directly substituted t as 2 into ax plus b. So this is the final answer. Problem 6. Integral root of ax plus b dx. Now let me put ax plus b equals t. So in that case a dx equals dt. Right? So since I have a root here, it is nothing but ax plus b the whole power half dx. Right? So now this can be written as integral. What is ax plus b? It is t power half dt. So dx is dt by a. So I have 1 by a. Right? So this is 1 by a. What is integral t power half? It is t power half plus 1, which is 3 by 2 divided by 3 by 2 plus c, which is nothing but 1 by a into 2 by 3. And what is t? T is ax plus b. So you have ax plus b whole power 3 by 2 plus c. So this is the answer. Seventh one, integral x into root of x plus 2 dx. Right? So now let us put x plus 2 equals t. So if I put x plus 2 equals t, so you get dx is equal to dt. And what is x? X is nothing but t minus 2. So we have to do all these substitutions. So I have integral x is nothing but t minus 2, and this is t power half dt. Dx is nothing but dt. Now let me open the brackets. So t into t power half is t power 3 by 2, right, minus 2 into t power half dt. Right? So now I can integrate both of them separately. Integral of t power 3 by 2 dt minus 2 into integral t power half dt. So we have t power, so this is of the form x power n dx, right? So I have t power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 minus 2 into t power half plus 1 is 3 by 2 divided by 3 by 2 plus c. And what is t? T is x plus 2. So let me substitute. So you get x plus 2 whole power 5 by 2 into 2 by 5 minus, so this 2 goes on top, it becomes 4 by 3 x plus 2 whole power 3 by 2 plus c. So this is the answer. Eighth one, integral x into root of 1 plus 2x square dx. So very easy, since you have 1 plus 2x square under root, I have to make this substitution as 1 plus 2x square equals t. So you have 2 into 2 is 4x dx equals dt. Or what is x dx? It is 1 by 4 dt. So x dx, you're going to substitute it as 1 by 4 dt, and this is t, so t power half. So you have 1 by 4, so this is t power 3 by 2 divided by 3 by 2, so 2 2s are plus c. So this is 1 by 6, 2 into 3 is 6, t is 1 plus 2x square whole power 3 by 2 plus c. So this is the answer. So observe, let me make this substitution, that is put x square plus x plus 1 equals t. So you get 2x plus 1 dx equals dt, right? So here from this expression I can take 2 common. So if I take 2 common, I get 2x plus 1 into, this is x square plus x plus 1 whole power half dx. So 2x plus 1 dx is dt. So this is nothing but 2 into t power half dt. So this is 2 into t power half. Integral is t power 3 by 2 divided by 3 by 2 plus c. So this 2 goes on top, it becomes 4 by 3. And what is t? T is x square plus x plus 1 whole power 3 by 2 plus c. A very easy problem. So integral dx divided by x minus root x. So if you observe this, I can take root x common in the denominator. So you get root x minus 1. Okay, so now let me make the substitution. Root x minus 1 equals t. Right? So here differential of root x is 1 by 2. X power half minus 1 is 1 by root x dx equals dt, right? So here observe that I can substitute dx by root x as 2 dt. So this is 2 into, so this whole thing becomes dt now. So 2 dt is dx by root x divided by t. So you have integral of 1 by t is log t plus c. So which is 2 into log of t is root x minus 1 plus c. Find the integral of x divided by root of x plus 4 dx as x is greater than 0. Now let us put x plus 4 equals t. So if x plus 4 equals t, what is x? X is t minus 4 for the numerator, and dx equals dt, right? So you have integral, this dx is dt, and what is x? X is t minus 4 divided by, denominator is t power half dt. So this is nothing but integral. So I can write this as t by t power half, which is t power half, that is 1 minus half, minus 4 divided by t power half of t power minus half dt. So if I integrate this, so this is of course t power half plus 1, which is 3 by 2 divided by 3 by 2, minus 4 into t power minus half plus 1 is plus half divided by 1 by 2 plus c. So now let me bring this 2 to the numerator. 2 by 3, t is x plus 4 whole power 3 by 2 minus, bring 2 to the numerator, 4 into 2 is 8, t is x plus 4 whole power 1 by 2 plus c. Now if you observe in the textbook, he has given the answer in a different format. So what has been done is, taking this expression, that is 2 by 3. So here from these two, you take t power half common. So you get t minus So if I take 2 by 3 common outside, so this is 8, isn't it? So this is nothing but 8 t power half, right? So I have taken 2 outside, you get 4. I have taken 1 by 3, so you have to multiply 4 by 4 with 3, which is 12, right? Plus c, right? So now substitute the value of t here. So let me write this here. So you get 2 by 3, and what is t? T is x plus 4 whole power half into, t is x plus 4, so x plus 4 minus 12 plus c. So you get 2 by 3 into x plus 4 whole power half into x. So this is plus 4 minus 12 is x minus 8 plus c. So this is the answer what has been given in the textbook. So either you get the answer in this form or you get the answer in this form. So integral x cube minus 1 whole power 1 by 3 into x power 5 dx. So now make the substitution. X cube minus 1 equals t. So this is 3x square dx equals dt. So what is x square dx? It is dt by 3. So I have x square dx, but I have x power 5. So x power 5 can be written as x cube into x square. So I have integral x cube minus 1 whole power 1 by 3 x cube into x square dx. So x square dx you substitute it as dt by 3. So you have integral t power 1 by 3, right? And what is x cube? X cube is, from this expression, it is t plus 1. So x cube is t plus 1. So this is t plus 1 dt by 3. So this is 1 by 3 integral. So multiply t power 1 by 3 plus t is t power 4 by 3 plus t power 1 by 3 dt. So this is 1 by 3. So integral t power 4 by 3 is what? So it's going to be t power 4 by 3 plus 1. So it is 7 by 3 divided by 7 by 3 plus 1 by 3 into. So t power 1 by 3 plus 1 is t power 4 by 3 divided by 4 by 3 plus c. So 3 and 3 gets cancelled. So you get t is x cube minus 1 whole power 7 by 3 by 7 plus x cube minus 1 whole power 4 by 3 by 4 plus c. 13th one, integral x square divided by 2 plus 3x cube the whole cube dx. So again you have 2 plus 3x cube in the denominator. So observe that if I differentiate x cube, you get 3x square and you have x square in the numerator. So put this as t. So substitute 2 plus 3x cube equals t. So you get 3 into 3x square dx equals dt. Or what is x square dx? It is dt by 9. Alright, so here you have 1 by 9 integral dt divided by t cube. So it is 1 by 9 integral t power minus 3 dt. So it is 1 by 9 t power minus 3 plus 1, which is t power minus 2 divided by minus 3 plus 1 is again minus 2 plus c. So this is minus 1 by 18. T power minus 2 is 1 by t square and t is 2 plus 3x cube the whole square plus c. So this is the answer. So here you have 1 by x into 1 by log x whole power m dx, where x is greater than 0. So again put log x equals t. So if I differentiate log x, I get 1 by x dx is equal to dt, right? So integral 1 by x dx is dt divided by t power m. So this is integral t power minus m dt, which is t power minus m plus 1 divided by minus m plus 1 plus c. So what is t? T is log x. So you have log x. So this can be written as 1 minus m divided by 1 minus m plus c. So this is the answer. So integral x divided by 9 minus 4x square dx. So again substitute 9 minus 4x square equals t. So when I differentiate this, I get minus 8x dx equals dt, or x dx is minus 1 by 8 dt, right? So you have minus 1 by 8 dt divided by t. So this is minus 1 by 8. So you know that integral of 1 by t is log t plus c, or it is minus 1 by 8 log of 9 minus 4x square plus c. 16th one, integral e power 2x plus 3 dx. So put the exponent 2x plus 3 equals t, right? So you get 2 dx equals dt, or dx is dt by 2. So you have 1 by 2 integral e power t dt. So integral e power t is e power t itself. So you have 1 by 2 e power, what is t? 2x plus 3 plus c. So integral x divided by e power x square dx. So here make the substitution x square equals t, or you have 2x dx equals dt, or what is x dx? It is dt by 2, right? So x dx is dt by 2 divided by e power t. So you have 1 by 2 integral e power minus t dt. Integral e power minus t is e power minus t into minus divided by minus 1 plus c. So the answer is, so I'll write the answer here, minus 1 by 2 e power minus t is minus x square plus c. So this is the answer. So this can further be written as minus 1 by 2 1 by e power x square plus c. So integral e power tan inverse x dx divided by 1 plus x square. So we know that differential of tan inverse x is 1 by 1 plus x square. So put tan inverse x equals t, right? So 1 by 1 plus x square dx is equal to dt, right? So you have integral e power t dt. So which is e power t itself. So it's e power. So integral e power t is e power t itself. So e power tan inverse x plus c is the answer. So here you have e power 2x minus 1 divided by e power 2x plus 1. So in such a case, what can be done is divide both the numerator and denominator. Divide numerator and denominator by e power x. So when I do that, you get integral. So I divide e power 2x by e power x, so you get e power x minus e power minus x. So you get 1 by e power x, which I am writing it as e power minus x, divided by e power 2x by e power x is e power x itself, plus here 1 by e power minus x is e power x is e power minus x, right? Okay, so now observe that if I differentiate the denominator, that is e power x plus e power minus x, I get e power x minus e power minus x. So that would give me an idea that I have to substitute e power x plus e power minus x as t. So if I differentiate this with respect to x, I get e power x minus e power minus x dx equals dt. So you have integral, this is 1 by t dt, which is nothing but log t. What is t? E power x plus e power minus x plus c. So this is the answer. So problem 20 is very similar to problem 19 of this form. So if I differentiate the denominator, I get the numerator itself. So put e power 2x plus e power minus 2x equals t. So if I differentiate this, you get e power 2x into 2 minus e power minus 2x into 2 dx equals dt. So if I take 2 common, you get e power 2x minus e power minus 2x dx equals dt. Or e power 2x minus e power minus 2x dx is dt by 2. So you have 1 by 2 integral dt divided by t. So what is integral 1 by t? It is nothing but log t. So 1 by 2 log of, I'll directly substitute. What is t? T is e power 2x plus e power minus 2x plus c. So you have to integrate tan square 2x minus 3. So how do we do this? So I do not know what is the integral of tan square x, but we know the integral of secant square x, and we know that 1 plus tan square x is secant square x. So we know that 1 plus tan squared x equals secant squared x, or what is tan squared x? It is secant squared x minus 1. So let me first write this in this format. So tan squared 2x minus 3 is secant square 2x minus 3 minus 1. Right? So now I have to integrate this with respect to x. So what is the substitution? Put 2x minus 3 equals t. Alright, so here 2 dx is equal to dt, or dx is equal to dt by 2. So now this can be written as secant squared 2x minus 3 dx minus integral dx. Right? So now put the value of 2x minus 3 equals t. So you get 2 dx equals dt, or dx equals dt by 2. So you're going to make the substitution only for this, the first term. So you have integral secant squared t dt by 2. And what is integral dx? It is nothing but x, right? Plus c. So you have 1 by 2. What is integral secant square t? It is tan t. So tan, what is t? It is 2x minus 3 minus x plus c. So this is the answer. 22. What is integral secant squared 7 minus 4x dx? So you have secant square. So therefore substitute 7 minus 4x equals t. So 7 minus 4x equals t. So minus 4 dx equals dt, or dx equals minus 1 by 4 dt. So you have minus 1 by 4 integral secant square t dt. And this is nothing but minus 1 by 4. What is secant square t integral? It is tan t. And what is t? 7 minus 4x plus c. So you have minus 1 by 4 tan 7 minus 4x plus c. Problem 23. Find the integral of sine inverse x divided by root of 1 minus x square. So we know that differential of sine inverse x is 1 by root of 1 minus x square. So put sine inverse x equals t. So if I differentiate this, I get 1 by root of 1 minus x square dx equals dt. So make the substitution. So here we get integral sine inverse x is t divided by, so this entire thing dx by root of 1 minus x square is dt. So integral of t dt is nothing but t square by 2 plus c. So what is t? T is sine inverse x the whole square by 2 plus c. So we have to find the integral. So observe that I can take 2 common from the denominator. So I can write it as 1 by 2 into, so this becomes 3 cos x, and then this becomes plus 2 sin x. So observe, if I differentiate the denominator, I would get the numerator, right? So differential of cos x is minus sin x, differential of sin x is cos x. So take the denominator, which is 3 cos x plus 2 sin x as t. So if I differentiate this, so you get 2 cos x, so I'm differentiating this, minus 3 sin x dx equals dt, right? So you get 1 by 2 integral, so this is dt by t, so which is 1 by 2 log. So we know that integral of 1 by t is log t, but what is t? T is 3 cos x plus 2 sin x plus c. So you have integral of dx divided by cos square x into 1 minus tan x the whole square. So we know that differential of tan x is secant square x. So I have cos square x in the denominator. Let me bring it to the numerator. So it becomes secant square x. And let me put 1 minus tan x equals t. So I make this substitution. So if I differentiate this, I get minus secant squared x dx equals dt. So this entire thing becomes equal to minus dt. So I have minus dt divided by t square. So which is minus. So we know that if I bring t square to the numerator, it becomes t power minus 1. So it is t power minus 2. So t power minus 2 plus 1 divided by minus 2 plus 1 plus c. So you get minus into minus 1 gets cancelled, so minus sign gets cancelled, so you get t power minus 1. So I can bring it to the denominator. 1 by t is 1 minus tan x plus c. So this is the answer. So you have cos of root x divided by root x. So definitely I have to take root x as t, make the substitution. So we know that differential of root x, it's nothing but x power half, which is 1 by 2 root x dx equals dt. So what is dx by root x? It is 2 dt. So therefore, so I have integral cos t dx by root x is, so I bring this 2 here, it is 2 dt. So what is integral of cos t? Integral of cos t is nothing but sin t. So you have 2 sin, what is t? T is root x plus c. So this is the answer, very simple. So integral root of sin 2x cos 2x dx. So definitely I have to substitute sin 2x equals t, because I know the differential of sin x is cos x. So if I differentiate this, I get cos 2x dx into 2, of course, equals dt. So cos 2x dx is dt by 2. So I have integral, this is t power half, cos 2x dx is dt by 2. So it is 1 by 2, t power half plus 1 is 3 by 2 divided by 3 by 2, 2 gets cancelled, plus c, of course, which is equal to t is sin 2x whole power 3 by 2 divided by 3 plus c. So now in this problem, let me substitute 1 plus sin x equals t. So if I differentiate this, I get cos x dx is equal to dt, right? So cos x dx is dt, so this is dt divided by t power half, which is nothing but integral t power minus half dt, which is t power minus half plus 1 is half divided by 1 by 2 plus c, which is, so this 2 comes on top, t is nothing but 1 plus sin x whole power 1 by 2 plus c. So you have integral cot x log sin x dx. So now if I substitute log sin x as t, so if I differentiate this, log of sin x is 1 by sin x into differential of sin x is cos x dx equals dt. So what is cos by sin? It is cot. So cot x dx equals dt, right? So cot x dx is dt and log sin x is t. So I have integral, so this becomes dt. So you have t dt. So integral of t is t square by 2, right? So what is t? Log sin x the whole square by 2 plus c. So this is the answer. So integral sin x divided by 1 plus cos x. Again, we know that differential of cos x is minus sin x. So substitute 1 plus cos x equals t. So if I differentiate this, I get minus sin x dx equals dt. Right, so I have sin x dx, so that is minus dt divided by t, right? So this is minus, so t power, so I have 1 by t, right? So integral of 1 by x dx is log x, so this is minus log of t. T is nothing but 1 plus cos x plus c. So in this problem again, let us substitute 1 plus cos x equals t. So you have minus sin x dx equals dt. So therefore you get minus dt divided by t square So it is minus. So if I bring t square to the numerator, it becomes t power minus 2. So you get t power minus 2 plus 1 is minus 1 divided by minus 1 plus c. So minus gets cancelled. So it is 1 by t, which is 1 by 1 plus cos x plus c. 1 divided by 1 plus cot x dx integral. So this is an interesting problem. So we cannot make any substitution as such. So now we know that cot x is cos x by sin x. So let me do that substitution. So 1 plus cos x by sin x dx. So if I take LCM here, this becomes sin x plus cos x by sin x. So this is dx divided by sin x plus cos x by sin x. So let sin x go on top. So I get sin x divided by sin x plus cos x dx. So now let me multiply and divide by 2. So I have 2 sin x here. So I have 1 by 2. So 2 sin x can be written as sin x plus sin x. In the denominator, I have sin x plus cos x. So what I do is, let me add cos x and let me subtract cos x divided by sin x plus cos x dx. So now sin x plus cos x by sin x is 1 plus sin x minus cos x divided by the denominator. So you get 1 by 2 into integral sin x plus cos x by sin x plus cos x is 1 into dx plus 1 by 2 integral sin x minus cos x divided by sin x plus cos x dx. Right, so now here let me substitute sin x plus cos x equals t. So I make the substitution. So differential of sin x is cos x minus sin x dx equals dt. But what do we need? We need sin x minus cos x. So what should I do? Let me take a minus sign here. So sin x minus cos x dx equals dt. So this is 1 by 2. Integral of dx is x plus 1 by 2. With a minus sign, integral, so numerator is dt divided by t. So therefore you get 1 by 2x minus 1 by 2 log t. What is t? Sin x plus cos x plus c. So this is the answer what we get. So the 33rd problem is very similar to the previous problem. So in the previous problem we had 1 plus cot x. So we wrote cot x as cos x by sin x. So similarly here we have to write tan x as sin x by cos x. So this is integral 1 minus sin x by cos x. Of course you have the numerator. So if I take the LCM, this becomes cos x minus sin x, and this cos x goes on top. So you get cos x dx divided by cos x minus sin x. So again let me multiply and divide by 2. So 2 and 1 by 2. So you have 1 by 2 integral 2 cos x will be written as cos x plus cos x, and then let me add and subtract sin x. So in the denominator you have cos x minus sin x, right? So now cos x minus sin x divided by cos x minus sin x is 1 plus I have this term. So you get 1 by 2 integral dx plus 1 by 2 integral. So here you have cos x plus sin x divided by cos x minus sin x dx. Okay, so we have to substitute the denominator, right? So remember that if I differentiate this, differential of sin x is cos x, differential of cos x is minus sin x. So the denominator has to be substituted. So put cos x minus sin x equals t. So if I differentiate this, I get, so here differential of minus sin x is minus cos x with a minus sign. Then you have minus sin x dx equals dt. So I have minus cos x minus sin x. So let me take minus sign outside. So this becomes cos x plus sin x dx. So cos x plus sin x dx equals minus dt is the substitution what we'll use here. So equal to 1 by 2 integral dx is x plus 1 by 2 with a minus sign integral dt by t. So you have 1 by 2x minus 1 by 2. Integral of 1 by t is log t, log cos x minus sin x plus c. Now you have integral root of tan x divided by sin x cos x in the denominator. Now we know that differential of tan x is secant squared x. So what I'll do is, let me multiply and divide by cos x. So I have cos x, I'm multiplying. In the denominator you have sin x cos x, and again I have to multiply cos x here. So cos x square is what I get in the denominator. Let me bring cos square x to the numerator. It becomes secant square x. So secant square x root of tan x dx, and if I bring this cos to the denominator, it becomes sin x by cos x, which is nothing but tan x. So here you have root tan x, here you have tan x, so it becomes secant square x divided by tan x the whole power 1 by 2 dx. So now you know what to do. Put tan x equals t. So tan x equals t, secant square x dx is equal to dt. So here we get dt divided by t power 1 by 2. So if I integrate this, what do I get? So I bring t power half to the numerator, it becomes t power minus half. So t power minus half plus 1 is t power plus half divided by 1 by 2 plus c. So the final answer is t, which is tan x. So tan x the whole power 1 by 2, 1 by 2 in the denominator, so this 2 will come on top, 2 tan x the whole power 1 by 2 plus c. So this is the answer. So substitute 1 plus log x equals t. So if I differentiate this, I get 1 by x dx equals dt. So very easy. So you get integral t square dt. So what is integral t square? It is t power 3 by 3 plus c, which is 1 plus log x the whole cube by 3 plus c. Very simple problem. So question 36. So I have x plus 1 into x plus log x the whole square divided by x. So let me divide x with the two terms here. So you have integral x by x is 1 plus 1 by x is what I have, into x plus log x the whole square dx. Alright, so now if I substitute x plus log x equals t, if I differentiate this, I get 1 plus 1 by x. So differential of x is 1 plus differential of log x is 1 by x, dx equals dt. So this term is dt, that is 1 plus 1 by x dx is dt. So you have integral t square dt, so which is t cube by 3 plus c. Right, so what is t cube? T cube is nothing but x plus log x. So you have x plus log x the whole cube by 3 plus c is the answer. Integral x cube sine of tan inverse x power 4 divided by 1 plus x power 8 dx. So here we need to perform substitution twice. So what do? So first let me substitute x power 4 equals t right? So you have 4x cubed dx is equal to dt. So this is the first substitution what we make. So x cubed into dx equals 1 by 4 dt, right? So x cubed dx is nothing but dt by 4, and you have sine of tan inverse t dt divided by 1 plus t square. So we know that differential of tan inverse t is 1 by 1 plus t square, right? So differential of tan inverse x is 1 by 1 plus x square. So instead of x we have t. So now let me make another substitution. Let tan inverse t be equal to u. So therefore 1 by 1 plus t square dt equals du. So this is another substitution what is being performed. So you have sine u, so tan inverse t is u, and dt by 1 plus t square is du. So you just have to perform integration of sine u. What is integration of sine u? Integration of sine u is minus cos u. So minus cos u by 4 plus c, which is minus cos, what is u? U is nothing but tan inverse t, and what is t? It is x power 4 by 4 plus c. So this is the answer. So integral of this term is minus cos tan inverse x power 4 divided by 4 plus c. So question 38 and 39 are multiple choice questions. So let's see which is the right answer. So question 38 is, you need to find the integral of 10 x power 9 plus 10 power x log 10 to base e dx divided by x power 10 plus 10 power x equals. So we have to choose one of the options. So what is this equal to? So make a substitution. So you know that differential of denominator is numerator. So let's substitute x power 10 plus 10 power x equals t. So you have 10 into x power 9 plus 10 power x log 10 to base e dx equals dt, right? So now you have integral 1 by t dt. So we know that it is log t, and what is t? X power 10 plus 10 power x plus c. So this is the answer. So you observe all the four options. You observe that the right option is D. A very simple problem. Question 39 again is a multiple choice question. So you have integral dx divided by sine squared x cos squared x. Now how do we proceed with the integration here? So I have sine squared x in the denominator. I also have cos squared x in the denominator. And in the numerator you have 1, right? So 1 into dx is dx itself. Now we know that 1 can be written as sine squared x plus cos squared x dx divided by sine squared x cos squared x. So what is sine squared x divided by denominator? You get 1 by cos squared x dx plus cos squared x divided by denominator is 1 by sine squared x dx. So this is integral of secant squared x dx plus integral of cosecant squared x dx. So we know that integral of secant squared x is nothing but tan x plus what is integral of cosecant squared x? It is minus cot x plus c, right? So you have tan x minus cot x plus c, and which is the right option? It is option B, right? So this completes all the problems from the exercise 7.2. So a lot of problems were given, 39 problems. So make sure that you solve each of them and practice, so that in the examination you will be able to solve any problem given in integration very easily. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.